Hello everyone. In this video I'm going to speak about orbitals and subshells. Let's get started. First of all, we have to understand how elements are distributed in the periodic table according to their subshells. First of all, we have three main blocks here in this periodic table. We have S block, P block, and D block. We have to understand that S block is occupying two groups, first and second groups, which means that all elements in the first group, they end by S1. And all elements in the second group, they end by S2. Why two groups? Because the capacity of the subshell S is 2 electrons. What about P block? We already know that P can take up to 6. For that reason, this group here is P1, P2, P3, 4, 5, and 6. Same for D. Here we have D1 until D10. So the element which is existing here has to end by P6. What about the number of the subshell? Is it 2P, 3P, 4P? It's depending on the periods. The periods, we have here 1, 2, 3, 4, 5, 6, and 7. So the element which is existing here, element Y, should end by 3s2. 3s2. The element here should end by 2s1. Orbitals and subshells. An orbital is a region of a space in which there is a high probability of finding an electron. We have 4 subshells, which are S, P, D, F. When we would like to fill the orbitals in the subshells with electrons, we have to understand how we can draw the orbital. We can draw the orbital as a box. The capacity of the box is 2 electrons. So the maximum number for electrons in the orbital is 2. So if you know that S, the capacity of S is 2, so we have only one orbital for S. For P, how many electrons? 6 electrons. So we can have how many boxes or how many orbitals? We have 3 orbitals. For D, 10. So we should have, of course, 1, 2, 3, 4, 5 orbitals. For F, we have 14 electrons. So we should have 7 orbitals, which could be represented by 7 boxes. But these boxes were drawn to represent how electrons are filling those orbitals. But the actual shape of S and P that we have to know, S has a spherical shape. We can just draw axes, x-axis, y and z, and we have here, this is a sphere representing S orbital. What about P? We have Px. We just said that we have 3 orbitals. So we have Px, Py, and Pz. Px is of course dumbbell shaped. All of them, all the orbitals for P are dumbbell shaped. We have Px on x-axis, Py on y-axis, Pz on the z-axis. It's very, very important when you are drawing the p orbitals to show the node like that. Very important, very, very important. In May 16, they ask the students to draw 1s atomic orbital and 2p atomic orbital. So students were expected to draw a spherical shape for S like that, and this was accepted. What about P? They just asked them to draw only an orbital. So if you draw X, that should be fine. If you draw Y, that should be fine. Z, that should be fine. If you draw all of them, it is perfect. How electrons are filling the orbitals? First of all, we have what's called Pauli exclusion principle, which says that the maximum number of electrons in an orbital is 2. So if I have a box representing an orbital, the maximum is 2 electrons. And if there are 2 electrons in an orbital, they must have opposite spin. Opposite spin. Why? Because electrons are negatively charged. To minimize this repulsion, they are spinning in different directions. As you can see here, this is correct, but this is wrong. They will never have the same spinning. Then we have Hund's rule, which says electrons fill orbitals of the same energy to give the maximum number of electrons with the same spin, which means that, as you can see here, they have to fill the orbitals with the same spin first. This is wrong, as you can see here, this is wrong because filling this one in this direction, other direction is wrong. Okay, you don't have to put 2 electrons in one orbital while you have a free orbital. So you have to distribute electrons in each single orbital first before you double them. Then you can, of course, draw electrons in the opposite direction. In May 16, they ask the students to draw the orbital diagram of C13 in its ground state. Of course, 13 is the atomic mass, the atomic number 6, and they gave them the following boxes. What you should do? You should distribute the 6 electrons, then you will write 1, 2, 3, 4, 5, 6.